we're going to look at 3 different designs in this chapter. The first one is completely randomized design. It is one in which each experimental unit is randomly assigned to a treatment. Each one. All right. So every single unit, whether it is, I don't know, whatever it is randomly assigned to a treatment. And that's what happens. So I have it all written out here in this example too. We're just going to kind of talk through it a little bit just so you can see how it is. Notice it's set up in steps. I'm going to scoot this up. The steps we just had up here in order to set up an experiment. Here are all the steps that we're using in this completely randomized design. All right. So a farmer wishes to determine the optimal level of new fertilizer on his soybean crop. We're not using subjects here, right? So that's nice. It's just, it's plants that we're going. It's not always about the people. Okay. Step 1, we have to lay it up, right? The farmer wants to identify the optimal level. That's what we're doing. So we define optimal level that maximizes yield. So remember, we have to say what the response variable is. It will be the crop yield. That's what our response variable is going to be. All right. Then step 2 is we're going to see some factors, because remember what is going to affect it. Some factors that will affect crop yield are fertilizer, precipitation, sunlight, and the method of tilling the soil, types of soil, plant, and temperature. So in this experiment, we will plant 60 soybean plants that we're going through. And then we're going to determine this level. So that was our experimental units, right? I forgot to say that. And then we're going to list the factors. So here's some factors. Fertilizer. So we identified them up here. And now in step 4, we're going to list them and say how we're going to account for that. So the fertilizer. This factor will be controlled and set at 3 levels. We wish to measure the effect on the varying levels as the response variable is the yield. So we'll set the treatments, which is our level, as follows. Treatment A are 20 plants with no fertilizer. Treatment B, 20 plants that receive 2 teaspoons. Treatment C are 20 plants that receive 4 teaspoons. So up here when we said 60 plants, we knew we were going to need 3 groups of 20, which is how we set that up. All right. Another factor, precipitation. The amount of rainfall cannot be controlled. So this is one of those situations where we can't be controlled. But the amount of watering done can. So each plant will receive the same amount of precipitation. So whether they're all being rained on or whether I'm going to modify this and take care of it because I don't have control over the weather, then I will use watering in order to pull that off. Sunlight, totally uncontrollable, but it's going to be the same for all of them. A method of tilling, we can control this factor by doing the same that we're looking at. Type of soil. Certain aspects, such as acidity, can be controlled. In addition, each plant will be planted within a 1-acre area, so it's reasonable to assume that it is equivalent. There may be a variation from plant to plant. To account for this, randomly assigning the plants to a treatment. So it's all just random of which ones go with which treatment. Temperature, you have no control over that, but it'll be the same for everything. All right, so we identified the factors, we worked with those, and so now step 5 is whenever we get down to business. So you randomly assign the plants. First, the number, we're just going to number the plants 1 to 60, and then randomly generate 20 numbers. We're going to pull those plants, and they go to treatment A. And then generate, number the rest of the plants 1 through 40, and get 20. Then they're going to go to treatment B. And then the rest of them are going to be in treatment C. Then till up the soil, plant the soybeans, and fertilize according to the schedule. At the end of the growing season, figure out how much did you get. That's what a yield is, right? How much did you get for each plant? What did it produce? And then determine any difference in yield among the 3 treatment plants. And that's what this is. So sometimes I think it's nice to see a chart like this because you can look at it. So randomly assigned from the beginning. I've randomly assigned these 3. Then I want to say treatment A, these random plants get no fertilizer. how much did they produce? If I get these 20 plants, they get the 2 teaspoons of fertilizer. How much did that produce? Group 3 of these 20 plants get 4 teaspoons per the water mixture, right? Which is what it is. And how much does that produce? Then you compare those, and then you come up with your claim based on that. All right? Good. And then you could say, from here, I see that 4 teaspoons was too much and 2 teaspoons produced the most yield. Well, this fertilizer wasn't any good, so no fertilizer actually was the best case scenario. Hey, who knows? Who knows? That's why you do the experiment, to come up with that. Neat, right? It's fun to see how it goes into play and not with people all the time. It's nice that they give this example of plants. I appreciate this one.